Good day, students, most especially grade 11 and 12. Today, I want us to take great care to closely observe this question, its own probability, and it's from one of the trial exam papers in South Africa. If we were to be honest from an intelligent point of view, we will come to a determination that these are questions that leave students with some back pain. Let's check question 12 here. What are we having? They are saying, given that A and B are independent events, so these are events that are independent in a literal sense, basically, determine the values of X and Y. So we want you guys to determine these values of X and Y. And these guys are part of the probabilities. So now that I'm told that these are events, what I'm going to do is I'm going to draw a sample space. Okay, I'm just going to draw a sample space and try to really analyze this scenario. So what we see is that these are two events, that is A and B, okay? And they can happen at the same time. Now, check something here, because that is independent. I'm going to draw that corner there to show that that is my S, is the sample space. Check, I'm having A and B just right here. I'm having the probability of A and B. So I'm going to draw this one as the probability of A. Now check something. They are saying that the probability of B only is 0.3 and the probability of the intersection, which is A and B, is 0.2. The probability of A only, that is X, okay? And the probability of not A or B is equals to Y. So these two events can happen at the same time. How do I see that? Is because I see the probability of their intersection, which is probability of A and B. Now, pay attention. I'm gonna draw the probability of B just right here. Yeah, let me just really group them. Just group everything here so that I can move it. Now, check something here. I'm gonna have the probability of A and the events A and the events B there. Now, they tell me that the probability of A and B is 0.2. That means at that region there, that's where you are going to have, I'm just going to shade this region for you guys. So that's where the probability of A and B are going to intersect. Basically, that's where they are going to intersect. So I'm going to write 0.2 here. That is 0.2. Okay, that is given. And then now the probability of B only is 0.3. I have 0.3 just right there. And then how about the probability of A only? The probability of A only, that is my X basically. I can really put this in white. So that is X. And then the probability of not A or B is Y. Think about it. If they say the probability of A or B, they're talking about this whole region just right here. They're including everything. So if they say not of that everything, is basically outside the events, okay? So I'm just going to put my Y then outside that event because this is the probability of not A or B. Pay attention. So now we want to find the values of X, but we are given a guiding factor here to say that these are independent events, okay? Now pay attention. I'm going to say that by definition of the independent events, it states that the product of the two events is going to be equals to the intersection of the events. So now I'm going to pen this down. The probability of A multiplied by the probability of B, that is going to equal to the probability of the intersection, which is A and B. Now check, the probability of A is what? It's everything happening in A, which is X plus 0.2. This 0.2 is part of A, by the way. So the probability of A is going to include the whole of that stuff there, that is X and 0.2. So when you add them, basically X plus 0.2 2. It's going to give you the probability of A. You multiply this by the probability of B. So the probability of B is basically adding 0.2 and 0.3. So if you do that, I guess it's going to give you 0.3, 0.5 basically. This is 0.5. That is going to be equals to the probability of the intersection, which is 0.2. That is 0.2. You can even see it from the diagram itself. So now you want to solve for x. What do? You divide both sides by 0.5. So you will have x plus 0.2. That is going to be, let me do that, 0.2 divided by 0.5. That is 0.4. That is 0.4. Therefore, if I take away 0.2 on both sides of the equation, x is going to be 0.2. If you solve for x in that space. Now, you want to solve for y. Look at y, where it's located. So y is sitting comfortably outside the two events. So, but what we know is that the sum of the probabilities is going to be equals to 1. Pay attention now. I'm going to say that the sum of these probabilities, probability of everything here, what you are seeing here, it must sum up to 1. Okay. So now I'm going to have a x plus 0.2 plus, I'm now summing up, including 0.3 there. And then that is going plus y. That is going to give me 1. The probability of everything in the sample space happening, it must give me 1. But I've just solved my x, by the way, to be 0.2. And then these ones are going to, let me just really copy them again to show that these are still there. Remember, you want to solve for y. Allow me to add these ones here. That is 0.4. That is 0.7. So I guess that is going to be 0.7 plus y there equaling to 1. Okay. Now I think it's 0.8. Hey? 0.2. Yeah, 0.7. Very good, because this is 0.4 plus 0.3. So that is going to tie down to 0.7. Be very careful. You can use calculator. Therefore, my y will be equals to 1 take away 0.7. And that is going to be 0.3. Thank you very much for watching.